Welcome to Excel Magic Trick number 265. Hey, if you want to download this workbook and follow along, click on my YouTube channel and click on my college website link and you can download the workbook Excel Magic Trick 265 to 267. Hey, in this trick here, we want to see cost accounting and how you can use linear regression to help you with cost accounting. Now, here's the situation. We have a caterer and we have some overhead expenses. And we need to bid on a job. And so we need to figure out per guest what our overhead expenses are. Now, one quick way to do that, or to calculate how much overhead per labor hour, and then you could do the calculation to get to guest, is to simply to have your data here from past 12 months. And take the total overhead expenses and divide it by the total labor costs. Let's do that right here. And in Excel, you create a formula by typing an equal sign in a cell. And then you click on the cell you want. Division is / and then I click on the other cell. So if I hit Tab now, I see that it's 1863. So that would be a quick and dirty way. But the problem is that includes variable and fixed cost. That would be called a mixed cost. And if we really want to do accurate analysis for a bid, we would like to be able to extract from this 1863 overhead per guest. We're going to extract from it and see what part is really the variable. One way to do that, and here's the finished result, we'll see how to do this in our video, is to do linear regression. You take these and plot them, and you get these plots, and then you add a trend line and an equation. What it does is linear regression gives you a linear equation, y equals mx plus b from algebra. The M is this $5.27 when it's rounded. That means for every 1 unit of labor we increase the variable cost by $5.27 plus this 38,501. Hey, that is the y-intercept. That means when we have labor hours of 0, how much is the overhead? It's 38,551. Get 501. Guess what? That's the fixed portion. 0x value, there's still some cost. Hey, that's fixed. It means no matter no matter how many you sell, that's the fixed cost. But as you increase each hour of labor, it's going to go up by $5.26. This is the x, this is the y. This is the independent or predictor variable. This is the independent or dependent variable. Now, what is r squared? There's actually two things we'll look at. We'll look at a measure called coefficient of correlation, which will tell us whether our relationship is direct or indirect. Here, as x increases, y increases. So the relationship is direct. Not only that, but what is the strength of the relationship? So we'll see how to calculate that, called coefficient of correlation. And then from coefficient of correlation, we can get r squared, which is called coefficient of determination. And that tells us how well our model predicts. It's not causation. It doesn't say that x causes y by 0.96. It just means that how much influence x has on y. So coefficient of determination, or r squared, the bigger it is, the better it is. Anything between 0.75 and 1 would be considered good. You have a model that can predict well. So for us to see 9.9623, that means we can use this variable cost here, 526, with confidence. Now let's go over and see how to do this from scratch. It's actually, the whole thing is pretty big here. So we're going to start at the top, zoomed in so we can see it. And then as we need, we'll move around. So here it is. We have a caterer. There's heavy scheduling during the summer and holidays, but not the rest of the time. And they cater lots of events. One event that we're going to analyze is a standard 3-hour cocktail party. And we need to figure out what the variable costs are for this cocktail party: food, beverage, labor, overhead. Here we have the length of the party. Here is our variable cost for food and beverage, which is easy to figure out. That is a bit of data that we already have. And then we need to calculate, because we have our our food and beverage, we need to calculate labor. Let's see, down here. A variable cost per guest for labor and variable cost per guest for overhead. But it's going to take a few steps. Now, the first thing we can look at is how much does hiring one person to work for us for 1 hour. So one labor hour cost will be $10. The trick is, if we're trying to do per guest calculation, we need to figure out what labor hours are per guest. Well, here it is. The party lasts 3 hours. And also from past data, we know that the number of guests per one laborer per 1 hour is 6. So it means if we have 6 people come into our event, we only need to hire one person. 12 people, we need to hire 2. So to get labor hours per guest, we simply take, hey, how long the party is, 3 hours, divided by number of guests per one laborer. So it's 0.5. Now, from that, then we could simply take our labor hours per guest times our labor hours per hour and calculate variable cost for labor. But now the tricky part, 1 hour of overhead cost. See, we knew what our labor was, because that's easy enough. But the overhead is the whole point of this problem, and that's where our linear regression comes in. Now, before we do that one, let me just go over here. This is from scratch. We have our, if we scroll down here, we can see I have a bunch of calculating stuff over here, and then our data is over here. So we actually need to add these up right here, and it looks like we already did that. I didn't mean to do that. I want to click here and show you how to add a column of data, because if you enter this in, you got to type all this in, but then you don't want to. You want to add it up quickly. The quick way to do it in Excel 2007 is home and then sigma. That is AutoSum. Notice that there's the screen tip that comes up, and notice it gives you a keyboard shortcut. I'm going to do the first one just by clicking here. Notice the dancing ants are dancing around the range. It's trying to be polite by guessing for you. It doesn't always guess right, especially if your data is set up funny. Our data is set up fine here, so it guesses just fine. It gets the right range. I'm going to hit Tab. Now I'm going to try that keyboard shortcut, Alt equals. And sure enough, it looks like it got it right. Now, why would Excel put a keyboard shortcut for AutoSum? Because it's the most common function. It's the only function that has a keyboard shortcut. Hey, try doing that in your interview when they ask you if you know Excel. I'm going to hit Enter. So we added these up. Now, another thing, since we're going to use these this data here quite often in our calculations to come up with our $5.27 for a slope, let's go ahead and name this so we don't have to keep highlighting it when we do a function, especially when we're way over here doing calculations. Now, if we were doing a calculation like a sum here equals SUM open parentheses, you could just click and drag, right? We all know how to do that, or some of us probably do. But instead of always having to scroll over and get the data, if we name this range something, then we can just type the name in. Here's how you name a range. And you only do this when you're going to use the same cell range over and over. So I have labor hours highlighted. And notice that's the name box. This is called the formula bar, and that's the name box. If you click in the name box, and I'm just going to type LH for labor hour, and then Enter. Now wait, now that range is named labor hours. So if you said equals SUM and typed LH, you can see that Excel 2007 knows it's a name. It shows you a little tag there. It also is blue, and you can also see the range there is highlighted. I'm going to click Escape. Now let's do the same thing over here. Click up in the name box, and I'm going to put OE for overhead expense, and then Enter. You can always check your ranges by using your drop down there. All right, now, so back to one overhead hour. Well, before we do the come up with the 527, let's just see how to do it the junky way, without considering variable or fixed, in essence doing a mixed cost. It would be easy, straightforward. I'm going to say equals, and then click over here, as we saw before. Click on that cell, and then / for division, and then click on that cell. And sure enough, it gives us 1863. Now, before we can do this one, we're going to scroll down here, and I've set up a little table here. We're going to, just like we saw on the chart, but different, we're going to actually calculate the value in the cell, not on the chart. Because what we saw in the chart over here, that $5.26, that was automatically generated by the chart wizard, which we'll see how to do, but you can't use it in a formula. Let's see how to use it in a formula. Luckily, there's a function built in like sum, but it's for slope, for linear regression, equals SLOPE, and you open parentheses. The screen tip is polite. It reminds you it wants the y's and then the x's. Well, our y's are OE. And notice in 2007, a little pop-up name comes up. Earlier versions that didn't happen, but the OE is blue, which means it got a range somewhere. Comma, and then the x's, I'm going to say are our labor. So it was LH. And notice it doesn't matter if you do lowercase or uppercase. I'm going to hit Enter. Notice when you click back here and hit F2 for edit, it puts the uppercase in. And sure enough, it got it. Is that amazing? That is so easy and simple. Now, how do we figure out the fixed cost? That's the intercept. Equals intercept. Known y's. So I'm going to take my OE, comma, and our known x's. That is our labor hours. Pretty amazing. Now, coefficient of correlation. That measures the strength and direction. The direction is this way. If it comes out, if this calculation comes out positive, it means the line's going this way. If it comes out negative, it's going this way. That means as x is increasing, y would decrease. All right, so let's see how to do. Oh, and that's the direction. The strength would be if they're all over if they're really close to the line, then it will be a large number near 1. And then our coefficient of determination, as we mentioned, that'll tell us the influence x has on y, and that's the r². That'll tell us whether our model is useful for making predictions. All right, let's click in this cell, and the function is Pearson. There's actually two functions. One's called Pearson. There's another one called correlation, and they both do the same thing. Pearson is named after the statistician who came up with it. Oh, but look at this. This screen tip is not polite. It says array 1, array 2. Because I don't know which one is independent and which one is dependent. No problem. You can click up here on the Insert Function button. And then in array 1, with your cursor there, it'll tell you that that needs to be the independent. So that's our labor hours. And then I'm going to hit Tab. And this is the set of dependents. That's going to be overhead. And then click OK. So the direction is positive, and the strength is very strong. Now let's do coefficient of determination. That simply is the square of this correlation here. And the way you do squared, or one way to do it, is use the caret symbol. That means exponent, and then type a 2. There's also a function, a built-in function for r². So it would be RSQ. And this one's polite. It says known y's and known x's. So the y's are the overhead, comma, and the x's are the labor values. And so there we get the same value we had on our chart. Now, we can scroll back up here. And 1 hour of overhead for us is going to be that $5.26. Now, scroll down here. Notice how this is a big unrounded number. We can't really use that in our calculation because we're talking dollars and cents. So we actually need to round that to 27. Now, instead of typing this in here, we're going to use the round function, equals round. And the number, I'm going to click on this number right here. And comma, and the number of digits, since we're rounding to the penny, and the penny is 1, 2 positions to the right of the decimal, you type the number 2. So it's always 2 for penny. If you're doing taxes, income taxes, it's 0 to the integer. But 2 is the way I remember it. 2 decimals to the right, and I count them, and then that's the number I put there. And sure enough, it gives us that 527. Now, variable cost per guess for labor, well, that's pretty easy. equals this 0.5 right here, 0.5, times our $10. Now, we don't have to round that. We don't have any rounding issue there. Now, variable cost per guest for overhead. Oh, yeah, we have a half an hour and an hourly rate, so multiply those two together, and we get our rate, or variable cost per guest for overhead. So there it is, $264. Now we have this, this, and this are three variable costs that we need to make our calculations. Right now we need our variable costs for food, labor, and overhead. Then we'll add them up and do our little calculation here. I'm going to say equals and scroll up and get that $17 and then enter. I need to get labor, variable cost for labor equals, scroll up and get my 5 from right there. And then variable cost for overhead, that's the one we just calculated. So that one would be right here, 264. Enter. Now I'm going to add these all up using the keyboard shortcut Alt equals. That's the keyboard shortcut for AutoSum. Excel is talking. I better turn that off. All right, now let's calculate our totals. For total revenue, we simply want to say equals and go up, and we have our $45 up here in our assumptions times, with our asterisks, that 120 guests. Now, variable cost is going to be similar, equals this total right here, which is times our number of guests. And then enter. So now we can subtract them, equals that one right there minus this one. And finally, we get our contribution to profit, $2,443.20. So if she wanted to bid this contract here now where she has more accurate variable costs, she could maybe reduce her price, right? Because she really wants to win the contract, and the benefit really is those future clients she might meet. So this analysis here with the mixed cost converted to just a variable cost gives us a better way of estimating what we can charge. Now let's go see how to create a chart from this data here. We'll create that XY scatter diagram. Now, you got to make sure your X's are to the left and your Y's are to the right, and you highlight with a label at the top. And then you want to go up to Insert, Scatter, and then I'll pick this one. Now I want to point to the edge, hold Shift and click and drag. I want to make it a little bit bigger. Not that much bigger. Now I want to increase the size of the fonts of everything. I'm going to click on this axis right here and right click. Notice that right click didn't work. I tried to click in charts. It's tricky to click on the right thing or right click sometimes. I got it the second time, but if you're having trouble with right click on a chart, there's a right click key. As long as I have the thing selected, the right click key is in between the window, control, and shift key on the right side of your keyboard. So I'm going to hold the right click key down and point to format or font. I'm going to change the size to 16. I'm going to do the same thing over here, right click key and then font, 16. I'm going to click on this title and hit the delete key. I'm going to click on this legend and right click and point to format legend. And I'm going to show this one at the top. And then click the close. Now I'd like to do some formatting now to this axis right here. I'm going to use the keyboard shortcut Control-1 to get to Format, Format Axis. Now the first thing is, you can see how the data points are way up here. I'd like to actually hack this off right about 38,000. So I'm going to say the minimum is 38,000. Then I'm going to come down to number. And notice that it's got it's using up a lot of real estate in this chart. So I'm actually going to click on currency. And then I'm going to go down to custom. And there's a cool trick here. See the $sign, the pound, and the comma? You need all of that. But if you delete everything afterwards and type a K, and then click Add. Excel knows it's, that K means 1,000, so it hacks it off at the 1,000 and puts a K there. Actually, the comma hacks it off at the 1,000, but that K lets us know that it's in 1,000. I'm going to click Close. Now I'm going to click here. Another way to change the font size is in the Home group, and then in the font size. Now we have our data points here, but it would be nice to show our linear equation. I'm going to right-click the data points and add trend line. I'm going to say linear and show our displayed equation in r squared. And I'd like to actually want to go backwards, and I'm going to estimate, just estimate here, maybe 1,500. Let's see if that works, or 2,000. And then click Close, and sure enough, it crossed it right there. So it shows us exactly at what point it crosses it. That's our trend line. Let's click, actually, let's get rid of these lines. I clicked on them and hit Delete. And then I'm going to put this equation underneath here. And same as before, we can change the font size. Must-sees here, the X and the Y. So we want to go out to Layout, Axis Titles. And let's do the vertical one first. Now I'm just going to type overhead expense. And then Enter. Another way to do that, since you have your words already in the cells, when we add our horizontal, I'm going to say below, you can actually hit the click up in the formula bar here, type an equal sign, and then click on some cell that has your label. That's a way of linking your labels to cells. Okay, so that looks pretty good right there. Oh, except for this, we definitely need to increase the font size. And here too. And you could add some color if you wanted it to the chart. We're not going to do that right now. Right click and or select any element and Control 1, and then you can change the solid color. So there it is. That's the XY that gives us the visual, the linear regression, the functions we saw, the visual portrayal, all very useful in analyzing this problem. All right, we'll see you next trick.